First of all, welcome. Thanks for coming. I'm Tom. I work at Immediate Media. I'm a senior UI developer. So my talk today is about unit testing. And I've named it Tell Me About the Code, because it's almost like a conversation with the code when you're closer to the code, when you're testing. So the idea is we're replacing intentions, so user intentions, developer intentions, with code assertions. So I like making stuff. I like making websites, games, services, all that sort of good stuff. I don't like it when stuff breaks. So the thing about making things is you get a really good feedback. You get really good feedback from when you actually make stuff. Not so much when it starts to break. So in the early stages, it's okay because it's like projects are quite small. So getting it working is quite fluid. You get to like a level. You make a level in a game, or you make like a page on a website. It's quite small. So if you're making a single page application, generally the feature set's quite small. So the difficulty comes in actually keeping the stuff working. So successful projects generally change over time. So if you were to make something quite successful, you might have the users ask you for feature changes. Those changes often they can introduce breaking code. So it breaks your product and it breaks your web pages. And the more this goes on, the more added complexity starts to mount up, and eventually you're having a bad time. So unit tests. Unit tests are a good kind of guard against this sort of thing, because you've got a way of getting quick feedback so close to your code base. So the idea might be that you've got so for example, interface tests, you've got kind of a conversation with your code in terms of like you've got something happening, but it's so far away from the code base that you end up having like a really you've got a bad relay. So our kind of interface tests take about an hour and a half, maybe 2 hours. So it's a long time to wait to find out if your code's actually broken anything. Unit tests are a good kind of cover for this, because you've got this kind of way of testing small increments of your code. So for example, you've got like a search app, you can kind of test it incrementally, like small pieces. So yeah, they're the reasons why we would do it. So yeah, they live close to the code modification cycle, so any developer can start this up, start like a test suite, run them, and they should be quite fast. You can automate them, so the good thing about that is that you don't have to really kind of do anything majorly intensive to get this kind of stuff in place. So we're going to go straight into what a unit test might look like. So this is an example of what a test suite and test specs might look like inside Jasmine. So keeping your tests maintainable generally means keeping them readable. You want to be able to say, okay, here's my module. In this case, you've got greeting. You want to make sure you can say, you want to make sure the code does what you intend it to do. So you give the specs, which are the it blocks, descriptive names. So in this case, we've got like should say hi or should greet the user by name. So from this, you get really good feedback from, let's say, here we've got like a bit of a test reporter. Here we're using Mocha, like a Mocha reporter. We've got Karma running in the background. So you've got pretty good readability here. You can kind of see what greeting's doing. Yeah, so this is basically what you want to do in terms of keeping your code readable. Another thing you want to do is follow the kind of pattern, arrange, act, assert. So whenever you've got a test, you want to keep it as minimal as possible. So you don't want to test too much stuff. You want to kind of test, generally, by this, we're talking about having a bunch of stuff set up for your preconditions. So if you've got like a test that is testing for a certain username, set it up to at the top of your test. Set up like a range section, so you've got like your object being arranged, and then after that you act on a certain method or you act on a certain function, feed some information in there, and assert at the end. And by that, this is what it would look like. So here we're testing a function called greet. It does very little. It just kind of says hello name. In this case, we've got like a test case that says so it's greeting. Should greet by name. So we've got an arrange area where we're setting up the preconditions, which is the name. We're feeding it into our act, which is greet. So we're making a call here. we get an actual return value back. So at the bottom we've got this kind of assertion, by which we send our assertion into expect, and we set up a matcher. So this is to be hello Gene. So you want to keep your test fast. Slow tests don't get run. Network calls are slow, which means the slower your tests are, they're just not going to get run. It's going to end up like interface tests or integration tests where you can only run them closer to the build pipeline. So you want to keep them quite quick. Just to cover some more things, you've got timeouts as well. They can slow down tests, file system access, or database calls. If they're on the same system again and you're not mocking them out, they can also slow down tests. So we're going to move on to spies, stubs, and mocks. So this is a way of getting around those initial problems. So for spies, spies are good for kind of testing what your code is doing to stuff that comes from the outside. So in this instance, we've got a method called invoke callback, or a function called invoke callback, which all it does at the moment is it's just calling callback with a couple of arguments. So this is just to keep it quite light in terms of what the code is actually doing. So here we've got a spec that's called, so a suite called invoke callback. We've got a spec that says should invoke the provided callback. So then we set up the callback. So we're arranging our stuff up front. We put this, so this is a spy, this is an anonymous sign-on I'm using here. The spy goes into invoke callback. And then once it's been called, so once we've acted on the function, we then assert certain things have happened. So down here we've got some sign-on asserts. We want to make sure that it's been called at least once. So we check that a callback has been called once. We also assert that it's been called with a certain set of arguments. So you can also do this with methods on objects. So in this example, we've got like a class called greeter. So it's just a small little thing. There's a constructor, takes a name, and there's a greet function on it, a greet method. So again, we've got a kind of a range area up here where we're constructing the greeter. We're setting up the spy to the method of greet on greeter. And then we act on greeter. So at the end of this, you end up with, so there's a couple of asserts here just to show what you can get out of it. The first assert is making sure the spy's been called. And the expect here is just showing you that the underlying spy is still being actioned. So it's not replaced it, it's still calling through. That's what sign-on gives you. And then we restore greet to what its original state was. Here, again, we're using stubs. So now we're using stubs. And we've got a function called validator, which takes a data provider, and we're just doing some, it's not really validation, but yeah, some kind of validation. So here we have another test. We've got a describe, which is the suite. Goes through. So this time we're stubbing out what we expect this thing to return. So at the moment we're expecting it to return bad value, so we're setting it up just to return a bad value. The good thing about this is you can test your kind of error states in your code. Here we know we're going to throw a type error. So, down here that's what we're saying we're expecting. So we just wrap this validator in a method. So expect calls this, and we expect it to throw an error of type error. Of a constructor type error and expected error as its message. Mocks are slightly different. So with a mock, you can mocks. So here we've got like an example of a callback delay. So all we've got like a constructor and a method that's called execute after. We pass it seconds and we expect it to call set timeout. So what we can do with mocks is set up the idea of like controlling time a little bit. So we've got a kind of, here we're using sign-on's fake, use fake timers. So we had set, so the clock is now replacing set timer set interval, date, and a bunch of other things that could be used around timers. And then, yeah, so we act on this. So we've got callback delay, execute after 1 second. The clock then ticks down, so we're at 998. We're asserting that the callback hasn't been called, and it kind of ticks down until it calls once. So this is just, so you wouldn't necessarily assert a lot of things in one function. You kind of want to assert one thing. But this just demonstrates the point that if you've got timers in place, you can kind of make sure things are working the way you expect them to. Then again, we at the bottom of this, we restore clock, so that should set all the kind of set timers, intervals, dates, all back to the way they should be. So effectively, we've got time travel in our code. We've got like so something that would take 1 second to without mocks to run, we now have effectively got milliseconds. Similarly, with fetch mock, you can do stuff with fetch. So fetch makes a call out to the network. We don't want that. So we can set up our fetch. So we mock out fetch. We call the method, which is kind of returning a promise. And then we can kind of assert on certain things, like in this example, fetch mock to be called. And also that the last URL used was the URL we passed in our test. We also catch the fail, just in case, because you want to fail fast on tests. So you pass in the error message, just to give you a bit of information about what's happened. So starting up new projects, I would say you want to kind of think about getting tests in early, because without that, you kind of miss a chance. So get a test harness in place. Confirm that it works by writing unit tests, make sure one fails, and then make that test pass. Execute the test runner, verify everything's working, and then you're on your way to making unit tests for your code. So in this kind of demonstration, we've been using Karma, so that's our test runner. Jasmine, sign-on, so Jasmine is the test framework. Sign-on is getting us all the kind of spies, the stubs, the mocks. And fetch mock is kind of mocking out fetch, so fetch API calls. And we're using mocker report for this beautiful report. Testing legacy code. So the problem with legacy code is there's kind of two ways to handle it. Like if you go into a project that hasn't got unit tests, you can either edit and pray, which is the kind of, so this isn't as bad as this GIF is leading to. It's kind of like, so you make sure all the stuff you're doing, you're kind of going through the code, make sure all the kind of areas that you're affecting are kind of covered. So you're looking through all the code, making sure you're not going to make too many mistakes. But at the end of the day, you're still praying. Like you've not got tests in place, so it's still going to be like, it's a long shot. The other is cover and modify. So this is a little bit slower, but it gets you in a place where you can kind of say, right, I've got tests around the kind of code I am touching, but you've got tests in the place that you're touching, so modifying it isn't as dangerous. It's still kind of dangerous because in legacy code you don't really know what everything's doing. So, but yeah, I mean, it's better than nothing. It's hard. In legacy code, it's hard to find scenes to get this stuff into. Sign-on helps a lot with that, so you've got kind of spies and so all the kind of spies, stubs and mocks are going to help you there. So covering is often done with manual testing in our experience in this company at the moment with legacy code. And unit tests won't catch everything. So you've got this, so with interface tests, integration tests and unit tests, you kind of catch more. You kind of want this kind of idea of like you've got unit tests as your base, so that you've got a lot of unit tests. So you get really quick feedback that way. Above that, get a few integration tests, make sure that you've got kind of like modules working together as you expect. And beyond that, set up UI like Selenium tests and stuff like that, just to get end-to-end tests in there. What you don't want is to have an ice cream cone. Because the problem with an ice cream cone is you've got UI tests take a long time already. So you just don't want to, you don't want too many long-running tests, otherwise you're never going to know what your code's doing. You're never going to run the tests. So recommended reads around unit testing, I would say working effectively with legacy code is number one. For me, if you're working with legacy code, it tells you a lot about how you can integrate tests. It tells you a lot about seams and things like that. Reliable JavaScript is good for getting the test in a state that can be tested. And also clean code by, obviously, Uncle Bob. Thanks a lot.